lights down. Those chairs are so comfy. If anybody falls asleep, wake up your neighbor at the end so don't get embarrassed. And also, don't forget, I'm with government. I'm here to help. But actually, today I'm here to talk with you, kind of share with you some of the trials and tribulations we've been going through on Dudleya verityi. It's in the Crassulaceae. Dudleya is a genus of about, actually, hold on, before I go, I'm going to give you a quick mental outline of what I'm going to try and do in this discussion talk. I'm going to try and give you a little bit of species information beforehand, discuss a couple of events and the effects they've had on Dudleya verityi, and the plans we've got coming up to work with it to prevent its extinction. So it's in the Crassulaceae, one of about 50 species in that genus. It's a narrow endaphic endemic. Oh, let's see, where am I? Okay. It occurs only at the very western edge of the Santa Monica Mountains. And there's Los Angeles, so it's a very narrow range. Over the past 20 years or so, we've been censusing about 3,500 individuals, and it's been on a slightly downward trend since then. This species is, as I mentioned, an endaphic endemic. It's limited to these north-facing volcanic rock outcrops at the very base of the Santa Monica Mountains. And when I turn my head like this, can y'all still hear me? Or? Okay, great. Okay, so it grows down in the fog belt, and you can see all the lichens, close association with the lichens. Where are we going here? Okay, I've just got notes here. I'm sorry, I've got a lot of numbers and points, and right now I'm not remembering all of them. Okay. On those rock faces, it can grow in a variety of little microhabitat niches. Let's see. It can grow in the cracks of the bedrock. It can grow right out on the rock face, bare rock face, no soil, just with the lichens. It can grow in little soil benches, just a little bit, in pockets of soil. Lichens, some of those lichens will catch the soil, and there will be a little bit of soil, and the lichen or the Dudleya will put out roots in there. About 99% of the individuals grow expressly on these rock outcrops. We do get a few individuals, maybe in my estimation about 1%, that will grow either in thicker soil benches on these rock outcrops or right beside the rock outcrops in the soil. And there's a very interesting dynamic going on. I'm going to try not to go into it too much. It's so complex and so many fascinating aspects about this that I could just go off and talk for another hour. But keeping on track, so Dudleya lanceolata is a soil species, much larger, more robust, grows out in the soil right all around all these rock outcrops. Verityi occurs just on the rock outcrops. And in the intervening areas, there are a bunch of plants that we really aren't quite sure what they are. They're intermediate in morphology, so I'm calling them putative hybrids. They may or may not be. And I'll talk a little bit more about how we're going to try and figure that out in the future. So we have essentially this species, 99% growing in association with lichens on the rock faces. I guess by definition that would make it an obligate lichen species. One portion of the life history of the species requires a lichen at some point, or they all use it. The ones that use it are the ones that survive. The ones that don't use it, very few survive. They act as a seed. They catch the seeds. Let's see. Reeser et al. Back in 2003 and some others, they actually published a number of papers about the associations between lichens and Dudleya verityi. So now we're getting into the events. This is, I guess we're in what I've heard people call the Great Drought. It is a drought of what I've heard is historic proportions. And it started, I think, back in the early 2000s when we've had some of the driest years in recorded history. 2001, 2002, had a couple of wet years. In the recent past, we're now, drought is a big topic of conversation. There are criteria, they have a classification scheme for determining how bad the drought is. A number of criteria, I won't go through those, from D0 to D4. Back in 2011, you can see we started meeting some of those criteria in California, even though we were very dry before then. And as time went on, you can see, and Dudleya verityi, just to make sure you all know, if I can balance, it's right down around in there. So just in the Channel Islands. So 2013, 2014, now we're in D3, and at the end of December, back at the end of 2014, we were D4, the most severe. And that's a closed system. It's not open-ended like Richter. So we've maxed out here. So just kind of quickly see getting worse and worse and worse. Another major stochastic event that happened to the species in 2013, May 2013, the Springs fire hit. It burned about 24,000 acres, which also went through the entire range of the species, which is pretty phenomenal. And we had mentioned that in the listing document, so I mean, we said that might be a threat, and that was one of the reasons we listed. Then here we go, we have this event coming in, burned everything. Not only did it burn it, it burned very hot, and there are almost even no stumps left out there across the entire 24,000 acres. There are a couple of small patches of vegetation. It's not like a mosaic, it was just a devastation. And even up until our last rain, it was like a moonscape out there. No fire followers or anything. So you can see with the green, the fire started at 6:30 right there at the Conejo grave, 6:30 in the morning, and by 3 p.m. the entire range of the species had burned. That's almost before any fire personnel could respond. So within 9 hours, less than 9 hours, we'd lost it all, which is pretty phenomenal. As far, I mentioned a few small pockets of vegetation for Dudleya. The 6 occurrences, we visited 4 of them. At one, there was about 2 square meters that hadn't either burned or cooked, and at another population, we had about 2 square meters that hadn't burned. Other than that, everything had either burned or cooked. Now, just to try and put this in perspective, keep in mind, IUCN, for critically endangered, for a species to be critically endangered, the criteria are, among other things, a reduction of greater than 90% over the last 10 years. The fire went through in less than 10 hours. So we estimated, and you can see over here, it happened right when we had a bloom going on in 2013. And plants that were blooming, if they didn't burn outright entirely all the way down, the volcanic outcrops acted as kind of like a wall or an amphitheater, and all the heat and the large shrubs just kind of heated everything up, and it was a synergistic effect, increasing the temperature. All the lichens, with the algae and the fungi associations, they died almost all of our lichens died as well. After the fire, we went through to a couple of places and tried to do a census to see what was left. And it was really hard. We had that typical succulent thing. If you cut a pad of a cactus off and set it down, it's not in the soil. Is it dead or not? It's going to take a long time before all the moisture goes. If you do it with a leaf from an oak tree, it's less ambiguous. With Dudleya being a succulent, they can live a while. I mean, what's the name? Live forever? When they made the first collections back in the 1800s and brought them back to England, they pressed them and they're still growing on the sheets. It's like, you can't kill them. Well, okay, maybe you can. Did I really say that out loud? Okay, so we found about 350 plants. So those are ones that are alive. All of those individuals, if that, to compare, if it had been humans, the 350 humans, all of them would have still been in the ICU and the burn unit. I mean, they were all really hurt. There were only very few that didn't. As a matter of fact, in 2013, after the fire, we only found about 10 individuals that still bloomed through the whole year. In 2014, we could only find about 25 individuals that had bloomed through the entire year. So that gives us an effective population size of about 25 for this whole species. Let's look at a couple of other species in the world. The northern white rhino. There are now, I hear, 5 individuals left. They are all past reproductive age, can't reproduce. It's got an effective population size of 0. It's functionally extinct. The condors, when we were back in the 80s, it got down to 22 individuals at one time. We went and captured all of them. They're doing great. The dusky seaside sparrow, when there were either 6 or 11 left, we went out and rescued them, but it was a little too late, and we lost that species. So Dudleya, we're at about 25 now, and we're trying to make sure we don't have the same thing. And we still have a lot of issues to deal with. Also keep in mind, with this species, because of the fire, we lost the entire seed bank, which was essentially, almost all of it, we believe, was in and among the lichens, which also either burned or cooked. The seeds are very small, so it's easy for them to heat up and die. 2013, we lost that seed cohort because we only had 10 individuals. We lost the 2014 seed cohort, so we haven't had any, essentially no reproduction, certainly no recruitment in the past couple of years. We lost all the pollinators, and we lost almost all of the essential lichens. The 2 most prevalent lichens at these sizes, oh my gosh, okay, well I can do that. Can you stretch out time for me, Nick?
Sure. No.
Thank you. Oh, we need a little time dilation. Where's Dr. Who when you need him? Okay, so these lichens are all near endemics to the islands, with only a couple of occurring on the mainland. As y'all know, I'm not a lichen expert, but I'm told that they grow very slowly, about 0.5 millimeter a year. This is one of the Niebla certicoides that had sloughed off, that had cooked and sloughed off the rock faces. I was told that this was about 100 years old. So the loss of these lichens, cannot be understated. The importance of them is critical. And since they live so long, it takes so long for them to get to the point where they're useful for Dudleya, so the Dudleya can use them for recruitment. If we can't get lichens back for 50, if it takes 80 years to get to the lichens, enough lichens to where we need them to support the Dudleya, it's going to be that long before we can get Dudleya back up above 25 individuals. So those 25 individuals have to survive for 50 to 100 years. But it looks like they can actually do that. Some of these stems are 20 to 30 centimeters long. And if each level of rosettes is 1 year of growth, if the stem grows 2 to 4 millimeters a year, we're looking at 50 to 100 years for some of the Dudleyas. And they produce tons and tons of seed. So just the seedlings, we get down to about 1%. And after that, this is less than 1/10 of 1% get to this stage. So what do we do? The plan we've come up with, and we've been working with a lot of people in universities, in the National Park Service, in the Fish and Wildlife Service, USGS, a lot of people. So we've got this plan. The first part is to try and rescue plants or plant parts, as many as we can. And we're developing an algorithm to kind of help us make the choice. What do we get? Because when you look at the plants out in the wild, it's really hard to tell. Is this alive? Is it dead? Is it going to survive? Is it not? So there are some that we're pretty sure aren't going to survive. So the plan is to rescue all of those individuals, bring them into captive propagation. Then we've got another little problem. Will they survive or not? The smaller they are, the less likely they are to survive. So we'll collect whatever we can that we think is going to die. Better to try and save it than let it go. There are plants that are doing fairly well that have multiple stems. We'll rescue part of the stems so we can get the genetic material from the stem and bring it in. So we'll have those. Then we have everything in the middle where we're not really sure. So that's where the algorithm comes through. We've got to try and come up, over time, look at the individuals, see what percentage die, what percentage live, see if we can correlate it with traits we're observing, and make an educated decision on whether to bring it into captivity or leave it out. And while we're doing that, one thing to think of, we lost about 90% of the rare alleles in the fire and the drought. We're down there. So if we only get 10% of what's left, that's another 90%. So we're down to like 1%, I think it is. Or someone do the math and tell me. So in order to collect 99%, or to have a 99% chance of obtaining even just half of the rare alleles out there, we have to get 30 individuals from each occurrence. We can't even do that because there aren't that many individuals. There are only that many individuals at 2 occurrences. So we're in a tight spot. Captive propagation of rescue plants, when we do get them, the plan is to have them in 3 places. Luckily, we have Steve McCabe, who's actually out here. Go talk to him and see what he says. He's the god as far as I know. I go to him for everything, Dudleya. So some things survive better than others. So anyway, we're going to have, rather than keeping everything at one place, in case there's a fire at a botanical garden. Have we heard about that lately, Santa Barbara? So we're going to have 3 places. The primary is up at UC Santa Cruz. Secondary is going to be at Santa Monica Mountains National Park. And the third is going to be at the Channel Islands National Park. So we have people there that are experienced with Dudleyas. So we're going to do that. Also, concurrently, we're going to do as much active management, and the goal is to keep everything alive in the wild as possible. If we don't have to bring it in, then that's great. But if we have to maintain them for 50 or 100 years, that's going to be difficult, but we will. And that's where the algorithm and the partners are making those educated decisions. And I've been talking with people in Hawaii who deal with these types of situations all the time, Marie Bergman and others. And so there are a lot of resources out there, and that's really great. Glad about that. We've got a number of activities set up. Misting for moisture augmentation, weed management. We don't want to have things competing with the Dudleya that germinate or are still alive. We don't want large melasma coming to have increased fuels, erosion control and soil stabilization. I couldn't get a picture I could use. The Camarillo mudslide. How many of you have heard of that? Seen the pictures? That mudslide occurred in the canyon where one of the 6 occurrences reside. I have no idea what the fate of that occurrence is. Shading without the lichens to help shade. We're going to need to do something. Fencing, herbivores. If we exclude everything, we won't let the pollinators in, can't keep out slugs and little bugs, can't keep out wood rats, it's tough, so we're working on figuring that. We want to monitor and keep track of every single individual out there, the habitat, the threats. If we do that, then we're going to be on a good course. Habitat restoration, very difficult with lichens, not been done in Southern California, but we have no options. We have to ensure that they keep going. Ex situ conservation of the wild seed, as well as seed reproducing captive propagation, as well as maintaining all the genets. Conservation research, I'll let you look at that. I kind of like the artificial lichen habitat research. Lichen-shaped objects. Maybe it's just the structure that's important, maybe it's something else. We're going to work on lichen reestablishment experiments in the meantime. And how do we put Dudleya verityi back out there? We can't take a potted plant and drill into the rock wall. Bare root plants, cuttings, seed, every seed that we put out there that germinates and survives would be predisposed, as opposed to growing them all in the greenhouse and planting them out there. And they may survive or may not. They're selected for the greenhouse. So any other possibilities anybody has, I would be very appreciative to hear. Please let me know. Here's my address. You can get in touch with me anytime. I'm here. And if you are someone that we haven't tapped into, I apologize. If you have some help and time, please get in touch with us. So this is, we're really interested in doing everything we can to keep the species alive. Thank you very much.